In this section, we're looking at how to solve rational equations. Our ultimate goal is the same as it's been anytime we've tried to solve equations in the past. We want to find the value for the variable that will make the given equation true, or values if there are multiple solutions. What this will generally entail in each case will be finding the common denominator for all of our terms and multiplying across by that value every single term to cancel out all of our denominators and then solve from there. In the case of example 1, we have a common denominator of y, so we'll multiply both sides of this equation by y over 1, which will give us 14 times y over y, plus 4 times y over y, is equal to 3 times y. If we've multiplied across by the right value, what we should see are cancellations that eliminate all values in our denominator, leaving us with a much simpler equation to solve, which in this case will be 14 plus 4 is equal to 3y, which will give us 18 is equal to 3y, or y is equal to 6. In example 2, we want to take exactly the same approach. We need to multiply through by our common denominator, which in this case would be 2x minus 3, and x plus 3. So we're going to take both sides of that equation and multiply through by that common denominator. On the left-hand side, the 2x minus 3 over 2x minus 3 will cancel, leaving us with 5 times x plus 3. And on the right-hand side, x plus 3 over x plus 3 will cancel, leaving us with 3 times 2x minus 3. From there, we'll distribute through on both sides to get 5x plus 15 is equal to 6x minus 9. Then we can subtract 5x from both sides and add 9 to both sides to arrive at 24 is equal to x. In example 3, we have a common denominator of x minus 3 times x plus 4. So again, what we'll do is multiply the entire equation, every single term on both sides of the equality, times this common denominator. Look for those cancellations to see what cancels out and then what's left over. On the left-hand side, we'll have 6 times that quantity x plus 4. On the right-hand side, we'll have negative 6 times x minus 3 plus 30. Since the x minus 3 and x plus 4 that we're multiplying by will completely cancel out the denominator for that final term. From there, what we want to do is look at distributing through. So we'll end up with 6x plus 24 is equal to negative 6x plus 18 plus 30. Grouping all of our like terms on the same sides will then give us 12x is equal to 24, or x is equal to 2. Example 4 starts off no different. In this case, we want to multiply through by our common denominator, which in this case is just x minus 3. This will leave us with x plus 2 times that quantity x minus 3 is equal to 3. And then we'll distribute through to get x plus 2x minus 6 is equal to 3, or 3x is equal to 9, which gives us a solution of x equal to 3. However, in this case, it's up to us to catch on to the fact that 3 can't be a solution to this equation. So in this case, even though we arrived at a value for x, there's no solution for this particular equation, because if we substituted 3 into the original function, we would end up with 3 minus 3 in the denominator, which would equal 0, and the denominator of a rational function can't equal 0, or the other way to say that is we can't divide by 0. So even though our process leads us to a solution, we need to make a point of going back to the original function to verify that that value can be a valid solution. Or the other way to say that is we need to look for any restricted values for these problems and compare those with our final solution. For instance, in example 3, if we set the denominator as equal to 0, we would find that not y, but x can't be equal to positive 3 or negative 4. In example 2, x can't be equal to negative 3 or 3/2. In that first example, we would get y can't be equal to 0. So we need to determine those values that y can't be equal to and check those against any possible solutions that we come up with. In example 4 then, if we come up with a value that's restricted, then we would say we have no solution.